I must say, when we got given cruise time in December in the central Barents Sea. But we've been extremely lucky with the weather and had a fantastic cruise. So my name is Monica Winsborough. I work at Cage as an associate professor, and I'll be leading this cruise together with Jochen. And the main reason why we wanted to come back to this area, Hopen in the central Barents Sea, is that it's an area which has very abundant seepage, probably the most abundant that we've seen so far. And this cruise, for the first time, we've brought an ROV with us. So this is the first time that we've been able to see with our own eyes what's happening at the seafloor. And for me, this was also my first cruise with ROV, so it's been extremely exciting to see the images of the seafloor. And Jochen can explain a little bit more about the ROV work.
Well, my name is Jochen. I'm working at the Geological Survey, affiliated to the Cage. So I'm quite familiar with this ROV. It's ROV Aegir 6000. The wonderful thing is with this cruise that we can combine the ROV work with acoustic work, sampling the air, sampling the water column, so that we could get an overview of the origin of the hydrocarbons to the fate of the hydrocarbons, where it actually oxidized. So we used the ROV 12 hours per day over 1 week, and thank God we had this wonderful weather. In the middle of the ocean, no waves. We could deploy the ROV 14 times, which is quite a lot for 1 week.
This was the largest delta plane which has been documented in Earth's geological history, 10 times as large as the Amazon today. That's the classical way of seeing it, that the hydrocarbons are generated down here. They get into the reservoirs, which this Jurassic package has very good sands almost all over the place. So when the hydrocarbons get in there, they start to move, accumulating in all these structures. And if there is a fault in the structure, they leak up to the surface, and where the ice has eroded into this, it will also leak, and where they are subcropping like this. And here you go directly from the seabed almost without any overburden into these old Jurassic and Triassic rocks. And that's also why we see all the leakage, I think, because there is so little overburden which can act as a buffer for all the hydrocarbons as they are moving upwards.
took quite a lot of samples with the ROV, and not just samples but also images. I think that's one of the most important things that I could do with the ROV, to take a series of overlapping images, and then I use the navigation data from the ROV so that I get precise coordinates for each image, and then I get like thousands of images and I put them all together and make one composite image of the seafloor. It's georeferenced, so then I can do spatial analyses as to which species are where, their distributions, how they're related to each other, and also overall you can see patterns of seepage. Like one of these sites which we didn't notice when we were just down there, but then in the mosaic we could see that there's a concentric pattern to where the bacterial mats are and where the chemosynthetic worms are. So this kind of overview you can really only get with an ROV.
Ja, nå skal vi bare fly ned igjen og se på riggingen, så kan dere begynne å løfte basketen når dere... Det er greit, om vi kjenner hvor veldig det kan vi løfte det.
Our goal as a microbiology team was to assess the impact of this seepage in the environment. So we look at sediment cores to see if microbes in the sediments are impacted, how they utilize the hydrocarbon, but also look throughout the water column, and then initiated some incubations for a long-term study at the university. The ROV on the cruise allowed us to have really pinpoint sampling, so we were able to target specific habitats that were varying within a few centimeters, such as bacterial mats, gas flare, or worm fields. So having the ROV was really one of a unique chance to have a state-of-the-art infrastructure on board.
Now can you maybe deploy it to this here?
On this cruise, I deployed the checkerboard experiment, which aims to measure bubble rising speeds and bubble sizes of flares. So I'm working on a model that models bubble dissolution in the water column and methane distribution basically in the water column. For this, I also need those bubble sizes and bubble distribution so I can implement it in the model. And of course, the dear CTs and discount bottles to assess a little bit how the methane plume basically around seepage sites is distributed.
You want the bubbles to come around here?
Yes.
Yeah.
Yeah.
They should not be there, they should be there.
Yeah.
Okay. What's on pick about so like a description?
Just some cameras with deep sea casing that we fix on the checkerboard to record bubbles from seeps, and they're rated to 1.7 kilometers. But it was really funny because I asked some salespeople for deep sea casing, for these GoPros, and when they showed us what they had, they were like, oh yeah, we have some until 40 meters, and I asked, do you have 500? But luckily those were in the department already.
Yes, freedom back.